Om Swastiastu. Hi, welcome back to my YouTube channel. This is myself, my name is Ika Adida Mayatra, and in this video, we will learn about sets, relations, and functions. Before that, don't forget to subscribe, comment, and like. So, enjoy to learn. Okay, for the first one, I want to tell you or explain about sets. A set is a collection of objects can be clearly defined and measured, so that it can be known whether or not they are included in certain sets. So the member associations is clear, but there is also what is called not set. If a not set, it means that its members cannot be clearly determined and cannot be measured. So, for the example, I want to tell you about the example of sets and not sets. Example of sets. Like the first one is rainbow color sets, the sets of natural number, and the sets of prime numbers between 20 and 50. So that about example of sets, and the example about not set. The first one is an interesting collection of paintings. Why the interesting collection of paintings is not sad? Because the meaning of the word interesting varies according to each person. So the uninteresting collection of paintings is a not sad. And the second one, the example of the second one is the sets of intelligent people. Why? Because there is no defined measure to measure someone's intelligence. Because that, the sets of intelligent people is a not set. And the third is delicious food sets. Why? Delicious food sets is a not set because the meaning of the word delicious varies according to each person. And that's about example set and not set. So I think sets can be expressed in three forms. The first one is with role, the second one is with sets forming notation, and the third is by registering its members. The first one is with words. For the example is A is the set of natural numbers between 1 and 5. You can write like this or like that. And the second one is with forming notation. For the example, A is sets natural number between 1 and 5. You can write like that. And the third is by registering its members. For the example, A is a set of natural numbers between 1 and 5. You can write A is 1, 2, 3, and 4. That's like that. Okay, that is about three forms. And the next is there are some important terms in a sense. This is very important. Like the first one is a cardinality. The second one is a set of universe. The third one is entity sets. The fourth is a Venn diagram, and the last one is a subset. So cardinality. What is cardinality? Cardinality is a number of members of different associations. cardinality to express the number of different members in a set using notation n. And examples to determine the number of the members of set A is like this, and then this means that you answered in the way is n A is a 7. Okay, that's about cardinality. The second one is about the sets of universe. The set of universe is a set of all elements which are the objectives of discussion. The sets of universe is determined by S. For the example, S is a natural number just like that. And the third is empty sets. An empty set is a set that has no members. For the examples, you can see in your phone or your laptop in this video. And then for the four is a Venn diagram. A Venn diagram is a set image to express the relationship between several sets. And the last one is subsets. Subsets are containing other sets. It's like A is subsets of B if all members of A are members of B. And the notation is just like that. Okay, that is about sets. For the next is relations. What the relation? Relation is mathematical sentence that states the relationships between a member of the sets and other members of the set. Set A and set B are said to have relation in their members of the sets that are paired with each other. The way to express the relation. The first one is an arrow diagram. The second one, the sets of constituent pairs, and the third one is Cartesian diagram. For the example, A or 1, 2, 3, and B is or ABC, just like that. And specific, the A is the vector of row diagrams, and the B sets of constitutive pairs, and the C is Cartesian diagram. Okay, the answers about that is A. A is a factor of B. B sets of constitutive pairs, and C Cartesian diagram. Okay. And how about relations characteristic? Okay. Relation characteristic is 4. The first one is reflexive. The second one is symmetrical, and the third is antisymmetric, and the last one is transitive. Okay, the first one is reflective. The relation R on a set A is reflective if A element R or every A is element A, just like this. And the second one is symmetrical. Relation R on a set A is symmetrical if that, and then that for all A, B is element A. And the third is antisymmetric. Relation R on set A is called antisymmetric if that, and then B, and then this, then A is B. For all A, B is element A. Okay, and the last one is transitive. Relation R to set A is called transitive if this and this, then A, C element R for ABC element A. Okay, that's about relation. relations. And next about function. Okay, what is function? A function is a relation from set A to set B if each number of set A matches exactly one member of set B. All members of set A or area of origin are called domains, while all members of set B or friendly relations are called codomains. The result of mapping between domains and codomains is called the function ring of result area. And then, as with relations, functions can also represent in the form of arrow diagrams consistent with sets of pair and with Cartesian diagram. So, from the arrow diagram above, we can conclude domain is A, that's like 1, 2, 3, codomain is B, 1, 2, 3, 4, and function ring is 4, 2, 3, 4. And functions can be denoted by lowercase letters like f, h, I. For the example, function f matches A to set B. Then you can write like that. Okay, the function's characteristic. There's a tree, a function characteristic. The first one is adjective functions, or we can say one-on-one. The second one is a subjective function, or we can say auto, and the third one is bijective function, or we can say one-to-one correspondence. Okay, the first one is injective functions, or one-on-one. If the functions like that, each B element B and only one friend in A, then the functions is called one-to-one or injective function. And the second one is subjective functions, or we can say onto. The function like that, every time B element B has a friend in A, then F is called subjective function or onto. And the third one is bijective function, or we can say one-to-one correspondent. And these functions or functions is both injective and surjective is called bijective functions or one-to-one correspondence. Okay, that's about the sets, function, and relations. I wish